Hello, my name is Jacqueline Zhao, and today I will be explaining how to turn the expanded equation of an ellipse into its standard form and graphing it. For today's example, I have the equation 16x squared minus 64x plus 25y squared minus 336 is equals to 0. Now, this equation is currently in its expanded form. To graph this, we need to turn this equation into its standard form. An ellipse's standard form is x minus h squared all over a squared plus y minus k squared all over b squared is equals to 1. Let's move this right here. As we can see, these are nothing alike. Now, to start turning it into its standard form, we can factor the 16 from 16x squared and 64x. So let's do that. So we have 16, factoring the 16 out, and that just leaves us with x squared minus 64, 16, you factor it to get 4x plus blank, because now we will be completing the square after we factor it out, plus 25, plus 25 y squared minus 336 is equals to 0. Now we can complete the square. To complete the square, we can use the reverse star method of factoring. So let me write it down. We know that in the star method, the top of the star should equal to a multiplied by c. The bottom should equal b. We have our variable x. The numbers here at the side, the numbers should multiply to equal AC while also adding to equal B. And we know that this should be A, B, and C. Correct? So let's plug in what we know. Plug it in. We don't know what C equals, so we cannot plug in the top here. However, we do know that B is equal to negative 4. So let's write that. Negative 4. X. Now, to get these sides here, we can divide the negative 4 by 2. Divided by 2, and that would give us negative 2 and negative 2. Now remember, the two numbers here add up to B while also multiplying to equal AC. And we know that A is equal to 1. So C should just be the number here. Negative 2 multiplied by negative 2 is equals to positive 4. Let's just erase. So now we know what the factored form is. 16, but let me just write this entire thing out. Sorry. So we got 4 as the C because 1 times C, 4. is equals to 4 because any number multiplied by 1 is that number. Now we've completed the square. But because we've added the c into the left side of the equation, we have to add it to the right side to balance it. But technically we didn't add 4 because we've factored the 16 out. So now we technically have added 16 times 4 is equals to 64. So we've technically added 64 onto this side of the equation. So we're also adding 64 here. 16, we've completed the square and we know that it equals to x minus 2 squared. Let's move this down a little bit, it's quite close. Plus 25 y squared. Y squared minus 336 is equals to not 0 but 64. So let's write it using, let's say, this color, 64. And as you can see, using the standard form here, all the variables are to one side of the equation. So let's add 336 onto this side. So we have 16 x minus 2 squared plus 25 y squared equals to 64 plus 336, and that should give us 400. Let me write it, this color, right? 400. And we can erase this because we've finished completing the square. But as you can see in the standard form, it the equation equals to 1. This is not 1, clearly. So to fix that, we can divide the entire equation by 400, where we get 16 over 400 can be simplified to be 1 x minus 2 squared all over, let's do this color, all over 25 plus, now 25 over 400 can be simplified to 1 y squared over 16. It equals to 1. So now we found the standard form. Wonderful. We found the standard form. Let's box it in, or I guess color it in. We found the standard form. Now using the standard form, we have to graph this ellipse. So let me insert a graph right here. Oopsies. Apologies. So let's graph the center. The center, we have x minus 2, y, and y squared. X minus 2 squared and y squared. That means the y squared is equals to 0, because, or the k is equal to 0 because y minus 0 would just leave y squared. So our y is 0. X minus 2 squared, or x minus h squared, x minus 2 squared. That means h is equal to 2. So let's plot our center using the orange. Okay. That's great, actually. So x is equal to positive 2, y is equal to 0. Positive 2, we have 1, 2, and just 0. So let's plot it right there. Now we know that these two numbers here are a squared and b squared. And to find our vertices and co-vertices, we need to know what a and b equals. So we just need to put it to the radical. So, because to cancel out a square, we need to radical the number, right? So a is equal to, radical 25 is equal to 5. So a is equal to 5. While radical 16 is equal to 4. B is equal to 4. And when A is greater than B, we know that it will be a horizontal ellipse. So we have to add and subtract 5 from our center to get our vertex. So let's do that. We're adding or subtracting 5 from 2. So 1, 2, 3, 4, 5. This is our first vertex. And subtracting 5. 1, 2, 3, 4, 5. This is our second vertex. This should be 5, right? Yes. Now we can find our covertex, which would add or subtract 4 from our y, which equals to 0. So let's do it. 1, 2, 3, 4. 1, 2, 3, and 4. Now we have plotted all the necessary points to graph this ellipse. And now we can just draw our ellipse like so. Here. This is our ellipse graphed. It's touching all of the points, right? Touches and ends at all of the points. And now we have graphed an ellipse using its expanded equation.